Follow the IUPAC rule to name an alkyne is similar to what we've done with other functional group. Our IUPAC naming would include the prefix, parent, and suffix. Suffix describes the functional group, and parent describes the number of carbon in the main chain contains the functional group. Prefix describes the substituents, stereochemistry, and all the other information that could complete the name of an alkyne. We're following these fundamental steps, and we're trying to find the longest continuous chain containing triple bond. We're going to start at the end, nearer to the triple bond, to number the main chain, and then we're going to identify the location of your triple bond and name the parent hydrocarbon using YNE suffix. We're going to look at these following examples to help us to apply the rules to name this compound. For the first compound, and obviously you have a triple bond that start with carbon number 3 and end by carbon number 4. So notice here, because your carbons here adopts sp hybridization and the geometry is linear around the sp hybrid carbon, ended up you write 4 carbons on the same line. Okay, so really remember that. Therefore, when you number your main chain, it'll start with carbon number 1, 2, 3, 4, 5, 6, 7. So your triple bond is on carbon number 3 and number 4. And therefore, the name of this compound would be 3-heptine. All right, so the second example, there are totally 1, 2, 3, 4, 5, 6 carbon in the main chain, and the triple bond is in the very middle, and therefore, when you try to number the main chain, you need to consider the substituents. With a methoxy substituents on this end of the main chain, we're going to number the main chain from the right-hand side. Therefore, the numbering of the main chain would be 1, 2, where the substituent is at, 3, 4, where the triple bond is at. So the name of this compound would be 2-methoxy 3-hexane. All right, and the following 2 examples contains more than one functional group, and a double bond and a triple bond. Under these circumstances, we need to come back, look at our step 4, when there's double bond and a triple bond coexist, and IUPAC rule suggests that double bond is of higher priority. The molecule is totally named as an ene. And to be specific, we need to identify where your double bond is at, followed by the name of the overall molecule as the corresponding alkene, followed by where the triple bond is at, and describing the functional group as YNE. So under that circumstances, when we look at the example number 3, we notice that the double bond is on carbon number 2, and the triple bond is on carbon number 2 if you count from the right-hand side. Since double bond is of higher priority, we need to number the main chain to make sure the double bond functional group has the smallest possible number. Therefore, our numbering would be 1, 2, 3, 4, 5, 6, 7. So this is a heptine. To name this compound, we're going to name it as 2-heptine 5 on. Every time when you have a double bond, always pay attention to the stereochemistry. In this case, you have a E stereochemistry over here, and always include the stereochemistry in the front of the name, in the beginning of the name. Okay, so the following example, we have double bond on the third carbon from the left hand side. We have triple bond on the third carbon from right hand side. But again, because alkene has higher priority, we're still going to number the main chain from left hand side. And therefore, our numbering for this molecule would be starting from the left hand side, 1, 2, 3, 4, 5, 6, 7. That's where the bromine substituent is at. Okay, and on carbon number 7, we notice that it is also a chiral carbon. So we need to describe the chirality over here, and it's an R. And the double bond, again, is an E. So we need to write down our name as R, E, put them both in parentheses, 7, bromo. Trying to write a little smaller. There should be a dash between 7 and bromo. 3, octene. 5, on.